All right, this video will be the 6-2 notes for independent and dependent events. I'm going to do this in a slightly strange order just to give you a heads up before I get going. I'm going to talk about example 1 first, then I will go through the exercise 1. After that, I will go through example 2, and then I will go through the exercise 2 on the back side of this sheet. Okay? So some of this we've already done in class, but I just want to give you guys a reminder just in case you need it while you guys are working on the homework section. So for example 1, it says 2 number cubes, 1 red and 1 blue are rolled. What is the probability that the outcome of the red number cube is even and the outcome of the blue number cube is 5? What we're going to do is we're going to break this up into 3 separate sections. First, we're going to talk about the red number cube. Well, on a red number cube, we have 1, 2, 3, 4, 5, and 6 on there. Now, as far as which ones are even, well, 2, 4, and 6 are even. Anytime we do probability, it's the thing that we want over the total number possible. So we want even, and there are 3 evens, and there are a total of 6 possibilities. So 3 over 6 is perfectly fine. I'm going to go ahead and simplify it. 3 goes into 6 twice, so our probability for this one is just going to be 1 over 2. Now for the blue cube, it says the blue number cube is a 5. So we want to know, well, for starters, there's still 1, 2, 3, 4, 5, 6 on the blue cube, right? So 1, 2, 3, 4, 5, 6. And what we want is a 5, so there's obviously only 1. So our probability is going to be 1, because there's only a single 5, out of our 6 options. So we still did want over possible on that. Now, whenever we're talking about probability and we're talking about one thing happening and then the next thing happening, we have to multiply those probabilities. So right now, actually, let me summarize this real quick. First step, we found the probability of just getting an even number on the red cube. Second step was finding the probability of getting a 5 on the blue cube. Third step is going to be to take those 2 probabilities that we have, so our 1/2 and our 1/6, and we're going to multiply these 2 probabilities. We multiply straight across, so it's going to be 1 over 12. So the probability of getting an even number on the red cube and getting a 5 on the blue cube is 1 in 12. Now to move on to exercise 1. So it says a card is drawn from a deck of 10 cards numbered 1 through 10. Unfortunately, I can't really show you cards on this, so what I'm going to do is I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. These are going to be our cards for 1 through 10. And then we also have a number cube, or a die, that is rolled. And our number cube says we're going to have 1, 2, 3, 4, 5, and 6 on it. Okay, so this is going to be our cube. Number 1, we want to know the probability of getting a 10 and then a 3. Well, looking at the deck of cards, there's only a single 10. So our probability is 1 out of 10. Looking at the number cube, there's only 1 3. So it's going to be 1 out of 6. So 1 out of 6. And I don't know if you can hear it, but you can hear my dumb dogs playing in the background. So now I'm going to multiply these straight across. 1 times 1 is 1, and 10 times 6 is 60. There's our probability. So now for number 2, we want to get 2 prime numbers in a row. So looking at that 1 through 10 deck, our prime numbers are going to be 2, 3, 5, and 7. So there are 4 things that we want out of 10. For our prime numbers on the number cube, we're only going to have 2, 3, and 5. So 2, 3, and 5. So our probability there is going to be 3 out of 6. I really meant to write that in blue. 3 out of 6. And again, I just multiply straight across. 4 times 3 is 12. 10 times 6 is 60. And both of those are divisible by 12. So 12 goes into 12 1 time, and 12 goes into 60 5 times. So the probability there is 1 out of 5. On number 3, we want to know the probability of 2 numbers less than 4. So here on my set of cards, I want something less than 4, meaning I'm not including 4. So these are going to be less than 4. So our probability for the deck of cards is going to be 3 out of 10. And then for a number less than 4 over here, well, there are 3 that are less than 10. So our probability on the second one is going to be 3 out of 6. And now I just multiply straight across. 3 times 3 is 9. 10 times 6 is 60. And 3 goes into both of those really nicely. So 9 goes into 3. I'm sorry, 3 goes into 9 3 times. And 3 goes into 60 20 times. So there's my probability on that one. On number 4, we want 2 even numbers. So an even set on this one, and then an even set on this one. So on our deck of cards, we've got 1, 2, 3, 4, 5 even numbers. So our probability here is going to be 5 out of 10. That's a terrible looking 5. Very sorry about that. All right, 5 out of 10. And then our other one, we also have, so what do we have? We've got 1, 2, 3 out of 6. So this one's going to be 3 out of 6. Pardon the dumb dog in the background. Now I can multiply straight across, but I'm going to go ahead and simplify these first. Both of these are just 1/2. So I'll multiply straight across, and I get 1 out of 4. I'm actually going to go ahead and cheat, and I'm not going to do these last two. If you got questions about those, you are welcome to come ask. So now I need to go ahead and move on to dependent situations. And guys, I know my pen is super loud on this iPad. I'm really sorry. I know that's very obnoxious. So now when we're talking about dependent situations, what that means is one draw or one roll or whatever else affects the next probability. So when one probability affects the next, we are talking about a dependent situation. All these other ones that we just did were all independent because one did not affect the next. I'll show you what I mean on this one. So for example 2, it says there are 6 black socks and 4 white socks in a drawer. You got to picture this in order for this to make any sense. So 6 black socks, 4 white socks in a drawer. If one sock is taken out without looking at the second, without looking, and then a second is taken out, what is the probability they will both be black? So I'm going to try to tap a little more lightly on this thing. Hopefully this works a little bit for us. First, we got to look at how many socks we're talking about altogether. We've got 4 here, and we also have, 6 there, and we also have 4 here. So we have a total of 10 socks. So our first probability is going to be something over 10. So we want to know the probability of finding a black sock first. Well, there are 6 black socks. Now, for the second one, we want to know of getting a second black sock. Well, if I didn't put that first black sock in there, or back in the drawer, I now have 5 black socks in there. And there are only a total of 9 socks left in the drawer. Once I've got both of those probabilities, I'm going to do what we've been doing before because we're talking about one thing and then another. We're going to take that 6 over 10, and we're going to multiply it times the 5 over 9. Then I just multiply straight across. 6 times 5 is going to be 30. 10 times 9 is going to be 90. And 30 goes into both of those really easily. 30 goes into 30 once, and 30 goes into 90 3 times. So our probability of getting one black sock and then another black sock is 1 out of 3. All right, now for the back page. And for whoever is wondering what on earth is going on in the background, these are what my agents are doing this entire time while I'm trying to record this. So now I actually have to get back to work. So for exercise 2, it says there are 4 red, 6 green, and 5 yellow pencils in a jar. Once a pencil is selected, it is not replaced. Determine each probability. So first we got to worry about how many pencils we actually have altogether. So altogether, I've got my 4 red, 6 green, and 5 yellow. So I have a total of 16 pencils. So pretty much every one of my probabilities is going to start out with something out of 16 on all of these. Something at 16, something at 16, something at 16. Oh man, and I'm probably not going to do all these. Sorry, pardon the dumb dog in the background. All right, so the probability of getting a red and then a yellow. Well, there are 4 reds. And if I've pulled out my 4 reds, if I've pulled out one of those reds, what I've got to do next, I'm going to multiply times the probability of drawing the yellow. There are only 15 pencils left in this group now, and there are still 5 yellows. So I've got my 2 probabilities, and I multiply straight across. 4 times 5 is going to be 20. And then 16 times 15, I have no idea. Had to cheat and use my phone. 240. For right now, I'm not going to bother simplifying these. I'm not going to simplify the rest of these. This one's pretty easy, though. I can cross out my zeros. I have 2 over 24, which is just 1 over 12. Now, for number 2, I want to find the probability of getting a green and then a yellow. Keep in mind, I'm not putting these back in. There are 6 greens, so I've got my 6 greens out of 16. times, now I want to get another yellow. Well, there are still 5 yellows, but there are only 15 pencils left. So now I'm going to take these, multiply straight across, and I get 30 out of 240. Again, that one's actually pretty easy to simplify, but I'm not going to bother right now. For number 3, yellow and then a green. Well, there are 5 yellows. Now I'm going to multiply that times, well, greens, there are 6 greens, but there are only 15 pencils left in, I don't even know what these things are in. They're in a jar. Okay, so 5 times 6 is 30. 16 times 15 is 240. Number 4, I want to know the probability of getting 2 greens in a row. So I've got 6 greens currently. After I've drawn 1, I'm only going to have 5 greens left, and I'm only going to have 15 left in the jar. 6 times 5 is 30. 16 times 15 is 240. Some of you guys are probably noticing a pattern right here. Yeah, they all just happen to be the same. They're not all, at least I don't think they're all going to be the same. Let's keep finding out. So number 5, probability of red and then a green. There are currently 4 reds in there. So if I drew one of the reds, I'm still going to have my, however many greens, 6 greens left. So 6 greens, and there are only 15 pencils left in the jar. 6 times 4 is 24, and then that is 240, which actually simplifies really nicely, but again, I'm not going to bother with it right now. Now I know the probability of getting 2 yellows in a row. There are currently 5 yellows in the jar, but if I draw one of them out, there are only 4 yellows left, and there are only going to be 15 in the jar. Multiplying straight across, I get 5 times 4 is 20, and 16 times 15 is that 240. Good luck on the homework on this part, guys. I'm going to hit a couple of them just to make sure that you guys are ready to go on these, but you're on your own for the rest. Okay, well, you guys are working on this section. This is the actual homework section. Keep in mind, these P's just stand for probability. So it wants to know the probability of getting a 1 and then an A. Number 3 says a prime and then D. Keep in mind, for 1 through 6, your primes, and I'm going to zoom in on here real far, your primes are going to be 2, 3, and 5. Okay? Consonants are just not vowels. Gosh, you guys have got to know that by now. A, E, I, O, and U are vowels. Consonants are everything else. Okay? Odd numbers just means you can't divide by 2. And then prime, again, whenever we're talking about rolling a die, it's going to be 2, 3, and 5 are your prime numbers. And again, consonant, we just talked about that. So keep those numbers in mind while you're going through this. This whole first section on 1 through 6 are all independent events. One roll does not affect the other. So you just find the probability of the first thing, find the probability of the second thing, and then multiply those two probabilities. I'm going to do number 6 with you real quick just to be on the safe side, just to make sure you guys are ready to go on this stuff. So I want to find the probability of rolling either a 2, 3, or a 5 on that number cube. Well, that's 3 options that I want out of the 6 total number of options on that cube. And I'm going to multiply that times. Well, now I'm going to look over here and I want to get a consonant. So not A, E, I, O, or U. So the only the only vowel I have there is A. So I have 3 options that I want out of 4. 3 out of 4. Multiply straight across. 3 times 3 is 9. 6 times 4 is 24. And both of those can be reduced by 3. So 3 goes into 9 3 times. 3 goes into 24 8 times. The probability of getting a prime and then a consonant is 3 out of 8. All right, for 7 through 10, you're talking about 2 different spinners. So just the probability of one, then the other. Once you know those 2 probabilities, multiply them. For 11 through 18, these are going to be the dependent situations, meaning that one probability is going to affect the other. So I'm going to do number 11 with you real quick. So it says there are 3 red, 1 blue, and 2 yellow marbles in a bag. Once a marble is selected, it is not replaced. That's why it's dependent. Determine each probability. So first, we need to find out how many marbles we have all together. So we've got 3, 4, 5, 6. So we have 6 marbles in the bag all together. So our first probability is going to be something out of 6. So we want to know for red. Well, there are 3 red marbles in there. If I draw a red one out, I now only have 5 marbles in the bag. So I want to get a yellow this next time around. And there are 2 yellows. multiply straight across. 3 times 2 is 6. 6 times 5 is 30. 6 goes into 6 once, and 6 goes into 30 5 times. So our probability is 1 out of 5. A lot of those are going to look very similar to that. And I'll do one of these for you as well. So it says there are 3 yellow cards, 6 blue, 5 red, and 2 green cards in a stack of cards turned face down. Once a card is selected, it is not replaced. Determine the probability. So again, we need to find out how many cards altogether. So we've got 3, 6 is 9, plus 5 more is 14, 15, 16. So we have 16 cards total. So our first probability is going to be something out of 16. We want to find the probability of getting 2 blue cards in a row. Well, the first time, there are 5 blue cards. The second time, there are only a total of 15 cards left, and if we drew one of the blue ones, there are only 4 blue cards left. So again, now I multiply straight across. 5 times 4 is 20. 16 times 15 is 240. And both of those simplify. That's 2 over 24, and then 1 over 12. The rest of these you guys are on your own for. If you've got questions, come into tutorials or ask, and I will come by and help you out.